I am so excited to go over this section with you. This is a big time section with some simple ideas that go over how we know when a function is increasing or decreasing based on its derivative. Let's check this out. So we've got, check out the graph below and match each inequality or equation with the correct part of the graph. All right, so basically we're looking at this graph of f of x and we're basically asked to say, where is f prime greater than 0? That's basically saying where are the slopes of the tangent line positive? Okay, well, that would be here, right? If you put a tangent line anywhere along this interval, even right there, all of those tangent lines have positive slopes. So I'm going to put f prime greater than 0 on that interval right there, whatever that interval is. Then we're looking, where is f prime less than 0? Another way of putting that is, where is the slope of f negative? Well, that would be all here, right? So that'd be all where the slope of f is negative. And then here we're asked, where is the derivative equal to 0? Or in other words, where does f have a horizontal tangent line, or neither going up nor down? Well, that would be all here, because all in this interval right here, f prime of x, or just f prime, is going to be equal to 0. And I should have put f prime less than 0 here. That's it. That's all we're looking for. So let's just keep it simple. All right, let's advance that a little more. So what are my conclusions? Your conclusions. Well, what does it mean to increase? It says f of x is increasing when? Well, increasing can look like this, or it can look like that as a part of a graph. Well, we noticed in this last graph, just to bounce back, that f prime was greater than 0 when f of x was going up, when f of x was increasing. So it's that simple. So when f prime is greater than 0, f is increasing, right? Where the tangent lines are positive. F of x is decreasing when? Well, it stands to reason it would be the opposite of this, and that's true. Here are the two ways that we could decrease. We've got a graph that looks like that, or a graph that looks like this. And of course, you could have a line too, right? You could have a positive line or a negative slope line. At any rate, f of x is decreasing when f prime of x is less than 0, where the slopes of the tangent lines are negative. That makes sense. We're going down, right? And we see that in our last graph that we just took a look at. Here we go. The f of x graph was going down. It was decreasing. Decreasing means that as you go from left to right, the y values get less and less. Increasing means as you go left from right, your y values get more and more. That's it. Very simple. Always reading it from left to right, though. That is important. And then f of x is constant or flat when, we saw that in the last graph, f prime of x was equal to 0. Makes sense, right? And that's just when you have a either horizontal tangent line or just a straight horizontal line, and we saw that right here in the middle of the graph. That's all. So that's a big idea, though. Keep those pictures in the forefront of your mind. One last time, f of x is increasing, right? Going up from left to right if f prime is greater than 0. We're decreasing, going down from left to right if f prime is negative. And then f of x is constant as long as f prime is 0. So do you have to memorize it? I mean, you could. Or you could just visualize it. Do it with your hands. F prime positive, f prime negative, f prime 0. It's pretty sweet. All right, here we go. A problem that involves this idea. Find the open intervals, meaning don't include the endpoints, on which the following, so this graph of that function, is increasing or decreasing. Now, I put the graph over here so we can illustrate why our answer makes sense, but let's do this algebraically. So where we're increasing, just kind of get your idea down on the page. We want to know where is f prime greater than 0. Decreasing, we want to know where f prime is less than 0. Sweet. So we've got to find the derivative here. It tells us a lot about this function. So I've got f prime of x is equal to, the derivative of this, 3 times 1/3 is just a 1, very convenient, x squared minus 4x. Now, how do we figure out where we're increasing or decreasing? Well, since the bound or boundary of where we could be positive or negative is at 0, then that's what we're going to set our derivative equal to. That's the place where our derivative could change signs. I mean, think about it. For a number to go from positive to negative or vice versa, we would have to go through 0 as long as that curve is continuous, right? So we check where the derivative is equal to 0. All right, well, we set it equal to 0, and we've got factoring of a GCF x times x minus 4 equal to 0. So essentially, we're looking for the critical numbers. Nice, that's what you're looking for. So you look for where the derivative 0 or also does not exist. In this case, it exists everywhere. So we get x equals 0 and x equals 4. Now what do I do next is a little bit curious. What I do is I draw what is known as a sine chart, right? And all that means is it's basically a number line where I mark down the zeros of the derivative as well as places where the derivative doesn't exist, the critical numbers. And I remind myself that I'm looking at the signs of f prime. What I'm concerned about are what the signs of f prime are, f prime, on all real numbers. So I'm going to test some values here. And basically, if I plug in a number to the left of 0 and it gives me a certain sign of the derivative, then the derivative is that value, that sign, negative or positive, the entire interval. Because again, the only place the derivative could change signs is where it's equal to 0 or doesn't exist. Okay, so what I'm next going to do is I'll test x equals, let's pick a value to the left here. I usually pick a fairly large value for a reason, because I don't actually want to plug the number into here and figure out what the actual value is. I'm only interested in, is f prime positive or negative? So I'm going to plug negative 10 into this. So in my mind, I don't typically write this down, but in my mind I'm doing negative 10, that's the derivative right there, times negative 10 minus 4. And I don't look at this and say, hey, what's the number this equals? I say I've got a negative times a negative, which is equal to a positive. So that's greater than 0. And I just put a little plus down there to indicate that f prime is positive for all x values less than 0. So that means on f, we're going to be increasing because all the slopes of the tangent lines on this interval are positive. It's that simple. Then I go to the next interval. Now here I have to pick a set value between 0 and 4. I'll pick 2. In my noggin, what I'm going to do is I take that 2, I plug it in usually to the factored form. It's easier to tell the signs. 2 times 2 minus 4. And I say that's a positive times what will be a negative, which is negative. So every number plugged into the derivative in this open interval is negative. So f will be decreasing, right? We'll have slopes that are negative. Simple. And then we pick another test value. I'll go x equals 20. Why not? Random big number. Doesn't matter what number you pick. We plug it in. I get 20 times 20 minus 4. Again, using this. That's positive times a positive is positive. So that means that f prime is positive for for greater than 4. And that means f is increasing because the slopes of all the tangent lines are positive. It's that simple. So I look at this, and now I've got my answers. So I'll say that f increases, and I'm going to show you the really formal way of writing this. F increases when f prime is greater than 0, which occurs, being very, very formal-like, which occurs on x is less than 0 and x is greater than 4. And you could have written that with an or you could have written it with interval notation. All right, let's do where f is decreasing. F decreases. So f decreases when f prime is less than 0, which occurs. So I'm being very formal here in case you're taking the A, B, or BC exam or have a professor that wants you to justify your answers, which occurs on, well, let's check it out, between 0 to 4. So I'm going to write that in interval notation just to mix it up, between 0 and 4. It's that simple. So again, you find where the derivative is equal to 0 or doesn't exist, your critical numbers. I like to write out a sine chart. This is not justification in and of itself. It's not a good way to say, I know why my answer is the way it is on the A, B, or BC exam. But many teachers will accept this as justification on their tests. I'm not going to show you a formal explanation every time, but I figured this time I'll show it to you. We tested values just to see where we're positive and negative on f prime. And that told us where f was either increasing, decreasing. And that was it. Notice also in my formal explanation, I start out by telling people what the qualification is for having f increase. F increases when f prime is greater than 0. That tells me where to look on here, as well as the reader. It's a great way to show that you know what you're talking about. Okay, so that is a lengthy example right there, but one that I think covers all your bases. The last little question is, what do you notice about the slopes of the graph at its relative extrema? Well, the relative extrema on this graph are at 0 and 4. And look at the slopes. The slopes go from positive to negative, and negative to positive, at the relative maximum and relative minimum respectively. More on that in a video coming soon. Peace.